Hello, I am Alihan Teke. I received my master's degree from the Department of Geomatics Engineering at Gebze Technical University under the supervision of Professor Taşkın Kavzoğlu. The title of the thesis is Applications of Ensemble Learning Paradigm and Advanced Hyperparameter Optimization Techniques in Landslide Susceptibility Mapping. So far, many machine and deep learning models and feature selection techniques have been introduced in the literature, and they have gradually become an integral part of landslide susceptibility mapping practices. However, identifying the proper ones for the nature of the problem amongst such a wide array of available options is a challenging task. These decisions also include the selection of correct features and the design of the internal mechanisms of learning algorithms. All of these can significantly affect the reliability and quality of the resultant susceptibility maps. To reveal the trends of current studies on these issues, the literature was reviewed by compiling a database consisting of 210 peer-reviewed articles from 2015 to 2021. In the constructed database, 5 major categories were analyzed. These are the global hotspots prone to landslide activities, landslide conditioning factors, landslide susceptibility modeling approaches, feature selection methods used for factor prioritization, and finally hyperparameter optimization techniques. The results show that limited research attention was paid to artificial intelligence tools such as feature selection, hyperparameter optimization, and ensemble learning in the context of landslide susceptibility mapping. To bridge these gaps and explore the origin of these issues, 4 research works mainly based on the ensemble learning paradigm and advanced hyperparameter optimization were performed. And this is the main novelty of the thesis, obtained with an in-depth literature analysis. The adapted methodology is based on 2 concepts, ensemble learning and hyperparameter optimization. So what is ensemble learning? It refers to a unified framework consisting of multiple individual models and generally aims to generate a holistic model with theoretically more robustness by integrating the predictive knowledge of different base learners. The paradigm can be integrated into many various AI-based fields. For example, 3 different applications of the ensemble learning paradigm were conducted in the thesis. In the first application, 3 different ensemble-based machine learning algorithms were applied to predict landslide susceptibility. In this study, we proposed the application of NGBoost, which is a novel member of the ensemble learning family. In the second specific work, 3 popular individual deep learning architectures, namely the CNN, RNN, and LSTM, together with their ensemble form based on the shear layer blocks, are employed for generating landslide susceptibility maps. Third, we propose the ensemble feature selection strategy to determine the optimal conditioning factor number in landslide susceptibility mapping. In this study, we initially combined the prediction of the 7 filter-based feature selection methods. Then the critical threshold for factor number was determined with the elbow point analysis. In the last application, the effectiveness of 5 advanced optimization algorithms was investigated. The hyperparameters of the XGBoost were tuned with these algorithms in the spatial prediction of shallow landslides. The natural question arising here, what is the contribution of these approaches to the quality of landslide susceptibility maps? The answer is clear. All of these artificial intelligence tools proposed in the thesis provided a significant improvement of up to 13% in terms of overall accuracy. The scientific outputs of the thesis can be evaluated under threefold. The first one is based on the literature review findings. This survey clearly showed that the untapped points related to artificial intelligence tools in landslide susceptibility mapping. The second one is the landslide susceptibility maps produced for different geographical contexts in Turkey. The last output is about which conditioning factors are more effective on landslide occurrences with the help of explainable AI. I believe that the landslide susceptibility mapping community can benefit from the adoption of the proposed concepts and the outputs, which allow the production of landslide susceptibility maps with more informative model predictions and also better reliability. Most of the thesis has already been published as journal papers and conference proceedings. In this slide, you can reach out the articles published in peer-reviewed journals, and 5 international conference proceedings were published from the thesis. Apart from this, I received a special invitation to publish a chapter for the book by Elsevier, and this chapter is based on the literature review made in the thesis and is currently under review. Finally, this is the end of this presentation. Thank you for your listening.